You ever, like, just look up at the moon? You know, that big old rock just hanging out up there?
Yeah, yeah, for sure. I mean, it's always there.
It is. It's, like, weirdly comforting, right? But it also makes you wonder, what's the deal with the moon, really?
Totally. There's a lot more to it than meets the eye, that's for sure.
And lucky for us, we've got a really unique perspective to dig into this time, right? We've got insights from, well, let's just call him Merlin. And Merlin, he's seen a lot, to say the least. He hails from the Andromeda Galaxy, which is, a bit of a commute.
Let's putting it mildly,
Yeah.
Andromeda. That's like next level cosmic perspective.
Right. So we're talking about billions of years of observations here, and he's dropped some serious knowledge bombs on us about our good old moon.
Knowledge bombs is right. We're going to be busting some lunar myths today, that's for sure. One of the biggest ones, that whole dark side of the moon thing.
Yeah, the dark side, like the ultimate mystery, shrouded in shadow.
Right. Exactly. But Merlin kind of throws a wrench in that whole image. Turns out there isn't actually a permanent dark side at all. It's more like every part of the moon gets its fair share of sunshine. Like 15 Earth days straight of sunlight, then 15 days of night.
Wait, so like a lunar day is 15 Earth days long?
Pretty much. It's all tied to how the moon rotates, or I guess doesn't rotate relative to us. It spins at the same rate it orbits Earth, so we only ever see one side.
That's why it's always the same face staring down at us, right? The man in the moon, or, whatever you see up there.
Exactly. We call that the near side, and the other side, the one we never see directly, well, we call that the backside. And it gets just as much light as the near side.
I remember when those first pictures of the backside came back from, I think it was a Soviet probe, Luna 3, way back in 59. It blew people's...
Totally. The backside was like this huge unknown, and then boom, we saw it. And it was just as cratered and mountainous and wild as the near side.
It really makes you think, right? Like, how much of what we think we know is just based on our limited perspective?
100%. Okay, ready for another lunar mind bender. You ever notice how, like, sometimes when there's a crescent moon, you can almost see the full circle, like a faint outline of the whole thing?
Oh, yeah. That's always bugged me. Like, what's that about? Ghost moon?
Well, Merlin would probably call it moonshine. He's got a pretty quirky sense of humor.
Sunshine, I like it.
But really, it's called earthshine. And it's all about the angles, the way the sun, earth, and moon line up.
Okay, I'm listening.
So picture this. You're standing on the dark part of the moon during a crescent moon. What do you see in the sky? A full Earth.
Whoa, like a giant Earth hanging there.
Yep. And not just any Earth. We're talking a blue marble, 14 times bigger than the moon appears to us, and 50 times brighter.
50 times brighter. That's got to be intense.
Oh, yeah, super bright. And all that light from Earth, it bounces off and illuminates the dark part of the moon. And that's what we see as that faint glow, the Earth shine.
It's like Earth is a giant mirror reflecting sunlight onto the moon.
Exactly. Pretty cool, huh? And get this, Leonardo da Vinci actually figured this out back in the 1500s.
Da Vinci? No way. That guy was like the ultimate Renaissance man.
Totally. He was way ahead of his time. Okay, now let's switch gears a bit. We've got to talk about the full moon names. You know, the harvest moon, the wolf moon, all that good stuff.
Yeah, I've always loved those names. They're so evocative, so connected to nature.
Right. Well, those names actually come from various Native American cultures. Merlin pointed out that they really highlight how intertwined people were with the seasons, the natural cycles.
Like they weren't just names, they were a way of marking time.
Yeah.
Right, a kind of lunar calendar.
Exactly. The names told you when to plant, when to harvest, when to prepare for winter. They were incredibly practical. The snow moon or hunger moon in February, for example, probably meant things are getting tough.
And then you've got the harvest moon, which is usually in September. That's got to be a welcome sight after a long summer of working the fields.
Totally. And then, of course, we've got the blue moon.
Ah, yes. The elusive blue moon. I'm still waiting to see one that's actually blue, though.
Me too. Sadly, the blue moon isn't actually blue. It just refers to having two full moons in 1 month. It happens every few years, so it's kind of special.
Speaking of special, there are all sorts of beliefs about full moons affecting human behavior, more babies being born, crime rates going up, that kind of thing. What's the real deal there?
It's one of those things that's been debated forever, right? Merlin had some interesting thoughts on this, actually.
Lay it on me.
So first off, he acknowledged that there are those statistics about, like, more births and whatnot during a full moon, but he also offered some alternative explanations.
Like what?
Well, for the babies thing, he kind of joked that maybe it's just, more romance happening under the moonlight.
I mean, it does make for a nice ambiance.
Right. And for the crime thing, he pointed out that a full moon just provides more light, which could make things easier for, let's just say, folks who aren't exactly law-abiding.
Makes sense. If you're going to break into a house, a brightly lit night is probably helpful.
Precisely. And Merlin even pointed out that when there's a full moon but it's cloudy, the crime rates don't go up. So it really seems like it's more about the light than some kind of weird lunar influence.
So basically, we can debunk the whole full moon makes people crazy myth.
I think so. Unless you
Sure.
count, like, werewolves.
Oh, right. The werewolves. Forgot about those guys.
Yeah, Merlin had a pretty good laugh about those. He's like, never seen anyone sprout hair and fangs just because the moon was full.
Well, that's a relief. I guess we can all sleep a little easier knowing that's not a thing. Okay, let's get back to the moon itself for a sec. We know it orbits us, but is it just going in a simple circle, or is there more to it?
It's a little more complex than just a circle. Merlin explained that the Earth and the Moon are actually doing this sort of dance around each other. Like a cosmic waltz. They're both orbiting around a common center of mass. It's not exactly in the center of the Earth, it's slightly off-center because, well, the Moon's got some mass too.
So it's like two dancers spinning around, but they're not holding on to each other right in the middle?
Perfect analogy.
Yeah.
And this whole Earth-Moon system, it's then orbiting around the sun. It's like a whole set of nested dances.
My head is spinning. So what about that thing I heard about the moon slowly drifting away from us? Is that really true?
It's true. The Moon is moving away from Earth at a rate of about an inch per year.
An inch a year? That doesn't sound like much.
It's not much in a human lifetime, no. But over millions of years, it adds up. And the reason for this slow drift, it's all down to the tides.
For tides, what do they have to do with it?
Well, those tides, the rising and falling of the oceans, they're caused by the moon's gravity pulling on the Earth. And that pulling creates friction.
Friction, like the kind that makes things slow down.
Exactly. The tides are very slowly slowing down Earth's rotation. And because of this weird law of physics called conservation of angular momentum, when the Earth slows down, the moon has to move a bit further away to compensate.
So it's like as the Earth's spin slows down, it gives that energy to the moon, and the moon uses that energy to move further out.
You got it. It's a pretty mind-blowing concept. And eventually, billions of years from now, the Earth and moon will reach what's called tidal lock. Basically, the Earth's rotation will slow down so much that one day will be as long as a lunar month.
Whoa, so like one side of the Earth would always face the moon and the other side would never see it.
Pretty much. And at
Yes.
that point, the tides would stop because the Earth and moon would be locked in this eternal dance, always facing each other.
That's so wild to think about. Okay, now a more down-to-earth question. Remember the Apollo missions when they planted those American flags on the moon? Can we see those flags with telescopes today?
Unfortunately, no. Even the most powerful telescopes we have aren't strong enough to see something that small at that distance.
Ah, bummer. I guess it would be pretty cool to see them, though.
Definitely. We can see craters and mountains on the moon with telescopes, but those flags are just too tiny. The best telescope we have, the Keck telescope in Hawaii, can only see things on the moon that are about half a mile across.
So what can we see on the moon with those really powerful telescopes?
Oh, we can see a lot. Craters, valleys, mountains, all kinds of amazing details. The moon's surface is incredibly diverse. It's just those really small objects like the flags that are beyond our reach.
Got it. So, no peeking at those Apollo landing sites just yet. Now, speaking of those first steps on the moon, I gotta know, what were the very first words spoken from its surface?
It's a moment etched in history, right? Neil Armstrong, as he stepped onto the lunar surface, said, "Houston, Tranquility Base here. The Eagle has landed."
Chills, man. Just chills. Okay, let's dive into some moon science. We know the moon doesn't have an atmosphere like Earth, right? But both the Earth and moon have gravity, so why the difference? Why can't the moon hold on to air?
Great question. It all comes down to escape velocity. That's the speed something needs to reach to escape a planet's gravity. On Earth, the average speed of gas molecules is way lower than our escape velocity, so they stick around.
So they're just not moving fast enough to blast off into space.
Yep. But the moon's gravity is much weaker, and its escape velocity is much lower, so even slow-moving gas molecules can eventually drift off into space.
So no air to breathe on the moon. What about temperature? Is it always freezing cold up there?
Not quite. Temperature in space is weird. It's not about how much heat there is, it's about how much heat something absorbs from the sun. A dark object, like a black shirt, could actually get up to like 270 degrees Fahrenheit in direct sunlight.
Whoa, so you could get a sunburn on the moon even though there's no air.
Well, not exactly a sunburn, but you get the idea. The moon, without an atmosphere to regulate temperature, experiences these wild swings between super hot in the sun and super cold in the shade.
Like a lunar tanning bed gone wrong. Okay, here's a question that's been bugging me. I always picture the moon as being like totally covered in craters, right? But I heard somewhere that it's not as cratered as Mercury. Is that true?
It's true, but there's a catch. The far side of the moon, the side we never see, is actually just as heavily cratered as Mercury.
Hmm.
It's the near side, the side we're familiar with, that has fewer craters.
Why the difference? Did the moon get hit more on one side than the other?
Not necessarily. Scientists think that billions of years ago there might have been volcanic activity on the near side, which covered up some of the older craters.
So it's like the near side got a facelift while the far side kept all its wrinkles.
Something like that. And speaking of perspectives, here's a fun one. People in the southern hemisphere see the moon upside down compared to us up north.
Wait, what? The moon flips over depending on where you are?
Not exactly. The moon is always the same. It's just our perspective that changes. Think about it. If you stand on your head, everything looks upside down, right? It's the same idea with the moon.
So it's just about how we're oriented to the sky.
Exactly. The moon's phases are the same everywhere. It's just the orientation that looks different.
Well, this has been a truly mind-expanding deep dive into the moon. I feel like I've got a whole new appreciation for our little celestial buddy.
Me too.
Yeah.
It's amazing how much we can learn about something that seems so familiar just by taking a closer look.
And it makes you wonder, right? With the moon slowly drifting away, what will our night sky look like in the distant future? Will our descendants even have tides like we do?
Fascinating questions. I guess we'll just have to wait and see.
Well, on that note, keep looking up, keep those questions coming, and we'll catch you on our next deep dive. Until then, this has been, well, this.